The question says the geometry of hydrogen sulfide and its dipole moment are. Okay, we have to determine geometry and dipole moment for hydrogen sulfide. Okay, geometry we can determine by hybridization, and then we can determine the dipole moment by finding the geometry. Okay, always keep in mind, if the central element in a molecule is having a regular geometry, okay, if the central element is having regular geometry, then its dipole moment will be 0. And if the central element is having lone pair, if the central element is having lone pair, its dipole moment will always be non-zero. Remember, based on this we are going to answer this question. Okay, first we talk about geometry, then we can find out first number of sigma bond, then hybridization, then geometry. Okay, hydrogen sulfide, sulfur is having how many valence electron? It is having 6 valence electron. Each hydrogen can form only one bond. This is one hydrogen, this is one hydrogen is there. Okay, now from here we come to know it is forming, sulfur is forming 2 sigma bond, and it is having how many lone pair? 2 lone pairs are there, 2 lone pairs. In determining hybridization, lone pair is equal to sigma bond, then total sigma bond we are getting how many? 4 sigma bond. From here we can get sp3 hybridization, and from here we can get tetrahedral geometry. But we have to, this is the regular geometry, but now we have to put 2 lone pairs. Okay, I put 1 lone pair here, I put 1 lone pair here. If you hide this portion, so what kind of geometry is coming? It is coming V shape. V shape, bent या angular. Okay, we can say V shape, it has V shape geometry. Yeah, we can say angular also. Okay, and we can say bent also. Okay, any of these name we can use. Okay, hydrogen sulfide is having bent, bent, angular, या V shape. And one more thing, when we talk about dipole moment, if the central element, as I said, if the central element is having lone pair, its dipole moment will always be non-zero. Okay, will always be non-zero. So you can see it is having angular, angular, angular. So we eliminated these 3 and D options, angular, and go for the non-zero, because central element is having lone pair. So its dipole moment will always be non-zero. It will always be polar by nature. Geometry angular, dipole moment non-zero, option A is correct. If you like this video, please share and subscribe to the channel.